Hello everyone, my name is Monika Bhushan and today we are starting lecture number 7 of linear algebra. In today's class we are going to see two very important topics. One is row echelon form of matrix and second is reduced row echelon form. So we are going to cover the concept of these two topics in today's class. But very first thing to start with these two topics is why we need to find the echelon form of a matrix, from where we have to use this echelon form. So matrix we all aware of, right? We know the concept of matrix. Till now we have understood many basic concepts related to matrix, and now we are going to find the rank of the matrix and even more advanced topics. The short form of row echelon form is REF and the short form of reduced row echelon form is RREF. Okay, this row echelon form actually help us to see what the matrix represents. Okay, so we are going to analyze the matrix, the nature, with the help of echelon form of the matrix. And similarly, this row echelon form and reduced row echelon form are going to be helpful to solve the system of linear equations. Okay, so it has the great role to find the solution of system of linear equations. So before jumping to those topics, we are going to today understand that what is this row echelon form first. Okay, fine. So now we are going to see what is echelon form of a matrix, or we write it REF of a matrix. So a non-zero matrix A is said to be in row echelon form if the following conditions prevail. So we have three conditions mentioned, and if a matrix satisfies all these three conditions, then we will say that this matrix is in row echelon form. Okay, so here we have written down a non-zero matrix A, right? Basically zero matrix is in RREF form. We'll see that what all those things mean. Okay, so if any matrix is given to us, some arrangement of numbers are present, so we have to check whether these three conditions are there or not. So very first condition is all the zero rows are below non-zero rows. Okay, so let us consider this example and then we will say that whether the conditions are satisfying or not. This example, suppose this matrix is A. Okay, and this matrix is what? This matrix is 3 rows and 4 columns, 3 cross 4 matrix, a rectangular matrix is given. Okay, now we are going to check whether zero rows are there in the matrix or not. If it is there, so it should be below all non-zero rows. What does it mean? Here we have total 3 rows, right? So very first row is not called as zero row. Why? Because here at least one element is non-zero. Eventually here all 4 elements are non-zero. Even this row is also non-zero row, but yes, this row is zero row because all elements are zero in this particular row. Okay, but we cannot say that each and every matrix will contain zero row. Okay, if we have zero row in that particular matrix, then it should be below all non-zero rows. Fine. So yes, this condition satisfies in this particular example. Okay, what is the second condition? Second condition says that the first non-zero entry in any non-zero row is 1. Okay, that means what they are saying, any non-zero row. Okay, so we are going to start with very first row in this particular matrix. So very first row is what? This is non-zero row. Fine, no? Because not all elements are zero. Here actually no element is zero. Fine. So this row is called as non-zero row. Okay, so the very first non-zero entry in any non-zero row is 1. Yes, so this entry is 1. Fine, no? So very first entry is 1. So this condition is also true. They are saying that first non-zero entry, that means you could had the elements present here, suppose 0, 0, 1, 2. Okay, this can also be present, right? So since you have at least one element which is not 0, so this row is non-zero row. Okay, but the very first entry is 0, the second entry is 0, that is also okay, but the third entry which is not 0, it should be 1. Okay, it should be 1. So if it was your 2, suppose it was your 2, then this condition will not get satisfied. Okay, so the second condition is what? The very first non-zero element should be 1. and the leading one in any row should be right side than the leading one in above rows. Okay, what does it mean? So this one is called as leading one. In any row, very first element, which is your 1, this will be called as leading one. Even this element 1 is actually leading one of this particular row. Okay, now we are going to say that in this particular matrix, this one is what? This one is leading one of row number 1, this one is leading one of row number 2, and row number 3 is 0 row, right? So we don't have any number other than 0. Okay, so they are saying that the very first non-zero element is 1. Okay, and here also very first non-zero element is 1, that is also okay. And then they are saying that the leading one in any row should be right side than the leading one in above rows. So that means the one should be in the right hand side, okay, of the previous row. That means this one should be right side of this above one. Suppose in this row also you had some number, and to be in row echelon form, the very first number should be 1. So 1 should not be present here. 1 should not be present here. 1 can be present here. 1 can be present here, right? Here 1 cannot be present. Here also 1 can be present, because this is what? This is your, this is right hand side of the previous ones. Even this one is also okay, because this one is actually right side of your previous one. Okay, so what is the third condition? So the entries below 1 in the same column are 0. Okay, till now we were talking about only the rows. Now we are talking about this column, that the entries below 1. Okay, that means below this 1 we should have zeros present in this column. Similarly, here we have the leading one. Okay, so in this column we should have 0 present below this one. Okay, so yeah, all these three conditions actually match for this matrix. So we will say that this matrix is in row echelon form. Okay, now we are going to discuss the second matrix. So this is, suppose this matrix is B. Now we are going to check whether this matrix is in echelon form or not. So one important point is what? In many textbooks you will find that they don't consider this criteria for echelon form. Okay, that means they say that the first non-zero entry in any non-zero row can be any number, if not necessarily this will be 1. Many authors say that this can be any number other than 1, but we are going to follow this also as the rule, that the first non-zero entry in any non-zero row should be 1. There are many benefits if we will be having this habit. The very first thing is it will reduce the calculation, and the second thing is in the reduced row echelon form, this is the criteria for all authors. So they say that 1 should be the first non-zero entry in any non-zero row. Okay, fine. Now we are going to see the second matrix, which is B. Okay, so what is the first criteria? The first criteria is to be the matrix in echelon form is what? All the 0 rows, if the 0 rows are present in the matrix, so those will be below non-zero rows. So we will check whether in this matrix is what? There are 3 rows and 3 columns. Fine. So do we have any 0 row here? So this is not 0 row, even this is not 0 row. Why this is not 0 row? Because at least one element we can see which is not 0. Yeah, this row, the third row, is called as 0 row. This is below all other non-zero rows. Fine. So first criteria matches here. What about the second criteria? The first non-zero entry in any non-zero row is 1. How many non-zero rows are there? This is your non-zero row. This is your non-zero row. 2 non-zero rows are there. So very first entry, which is not 0, so that should be 1. Yeah, this is 1. Similarly, in my second row, the very first non-zero entry is 1. Even this is also true. And the leading one in any row should be right side than the leading one in the above row. So this row, my second row, this leading one is actually right side of your previous one. Fine. So even this criteria completely gets satisfied. Now the third criteria is what? The entries below 1 in the same column are 0. Here is the 1. Here is the leading 1. Okay. So actually this is below leading 1. We should be writing down here below leading 1. So the entries below leading 1 in the same column should be 0. This is my leading 1 of my second row. So below should be 0. So this also gets satisfied. So yeah, this matrix is again my in row echelon form. Similarly, what about my matrix C? Suppose this matrix is C. So very first condition is what? All 0 rows are below non-zero rows. So in this matrix, we don't have any 0 row. Fine. Then we are not worried about this first point. What about my second point? The first non-zero entry in the non-zero row is 1. So first non-zero entry is 1. Here in my second row, first non-zero entry is 1. First non-zero entry is 1. That is okay. Now the leading one in any row should be right side than the leading one in the above row. So in my second row, this is my leading one and that should be right side of my previous leading one. Similarly, for my third row, the leading one should be right hand side of my previous leading one. Fine. So yeah, all these three criteria get satisfied. Then we'll say that this matrix is in row echelon form. So, but we are going to see few examples where the matrices are not in row echelon form. Fine. So here we'll say that these four matrices we will discuss why they are not in echelon form. So very first criteria is what? All 0 rows should be below all other rows, right? But here we don't find any, but here we say that this 0 row, right? No, this is the 0 row because all entries are 0 and that is actually above the non-zero row. So very first criteria doesn't match. So we will not check for any other criteria. We'll say that this matrix is not in row echelon form. What about my second matrix? So here we don't have any 0 row. Fine. So first criteria I'm not worrying about. But the second criteria is what? The very first element which is not 0 should be 1. Fine. So very first element which is not 0 should be 1. Very first element which is not 0 should be 1. That is okay. But this leading one of my second row, yeah, that is okay. That is on the right hand side of my previous leading one. But what about my third leading one? This third leading one is actually not on the right hand side of this one. Fine. This is right hand side of my first leading one, but this is not on the right hand side of my second leading one. So this criteria does not get satisfied. So we'll say that this matrix is not in echelon form. Okay. What about the third matrix? So here, yeah, first criteria is not, we are not worried about this first criteria because we don't have any all 0 rows. The second thing is the very first non-zero element should be 1. Very first non-zero element is not 1. So we will say that this is not in row echelon form. Again, some authors will say that this is okay. But the book which we are following, according to that, this is not in echelon form. And the fourth matrix is what? We don't have any 0 rows. Fine. So the first criteria we are not worried about. The second criteria is the very first non-zero element is 1. The very first non-zero element is not 1. This is actually minus 1. So we will say that this is not in row echelon form. Fine. I hope you understood what is row echelon form. Now we are going to see that what is called as reduced row echelon form. Okay, this reduced row echelon form is also called as normal form, is also called as canonical form of a matrix. Okay, so for a matrix to be in reduced row echelon form, very first criteria is what? The matrix should be in echelon form. The matrix should be in row echelon form first. Right, so the given matrix A is reduced to an echelon form first by applying the series of elementary row transformations. Yes, we have seen, right, in the previous class only we have seen that what are elementary row operations or elementary row transformations and what are elementary column transformations, right? Now, what we are going to discuss here that to convert a matrix into row echelon form, we will be applying the elementary row transformations. We will be seeing this in coming classes when we are going to find the rank of the matrix. Fine. What we have done till now, we have made the matrix in row echelon form. After that, what we have to do? Now we are going to do the column transformations, right, to reduce the matrix to one of the following four forms, and these forms are actually called as the normal form of any matrix A, or reduced row echelon form, or canonical form of a matrix. Okay, so these four forms are what? The very first is written as IR. Do you know what is IR? We have discussed it, right? This IR is called as the identity matrix of order R. Okay, what is your I2? I2 is what? Identity matrix of order 2. And how do we write this I2? What is identity matrix? The diagonal, the principal diagonal will be containing 1, all other elements will be 0. So this is nothing but I2. What is your I3? I3 is what? The principal diagonal will have 1 and all other elements of your this matrix will have zeros, correct? No? And this I3 is what? There will be 3 rows and 3 columns. So it is what? This is the square matrix. Fine, no? Okay, so this IR is actually the reduced row echelon form, right? So what we have done, we have actually converted any matrix into the reduced row echelon form, and then we have performed the column transformations. After that, we are not going to perform the row transformation. To convert the matrix from row echelon form to reduced row echelon form, we will be only performing the column transformation. Okay, fine. And then if the matrix comes under this IR form, then we'll say that this is your RREF matrix. This is your RREF form. Or we can have that this is IR0. This IR0 is what we'll see that. That means if the matrix is not a square matrix, the matrix is rectangular, we can have these zeros, the added column will have all zeros present. Similarly, this IR0 is what? This IR is nothing but it will be your actually square matrix, fine, no? Then after that, for any rectangular matrix, what will have? Other than all those rows which are not present in your identity matrix form, those will be 0. Similarly, this form is also okay. You can have extra zeros in your column, extra zeros in your row. What we are discussing, we are going to see the example for that. Okay. So what is your normal form or RREF form? So a non-zero matrix A is said to be in normal form if the following conditions prevail. And the very first thing is what? The matrix should be in row echelon form. Then only we'll be going to convert the matrix into the canonical form. Okay, the second important criteria is what? The first non-zero entry of a non-zero row is 1. And actually for us, since we have included this criteria also in our row echelon form, this is actually subpart of my first point only. So here strictly it should be 1. Okay. The third is what? All elements above 1 should be 0. So we are going to see these all conditions. Fine. So these are the examples of reduced row echelon form. But why? Okay, so first thing is for sure that this matrix is in row echelon form. This is in your row echelon form. Fine, no. If we will be adding one more condition, that condition is what? For any leading one, we have 0 only present even above that one. Okay, that means what? In other word, we'll say that we'll be having only one non-zero number. All other numbers should be 0. Right now, only one non-zero number, that is actually the number 1, and all other elements should be 0. Fine. So if this condition gets satisfied, so we say that this is actually reduced row echelon form. This arrangement of numbers is nothing but the identity matrix. This is nothing but your I3. Fine, no? This is nothing but your I3. So this I3 is actually your reduced row echelon form. Fine. Fine. What about this matrix? In any column, we have just one non-zero element, and that non-zero element is 1. Similarly, here also we have just one non-zero element. That non-zero element is 1. All other elements are 0. And here we'll say that here we don't have any non-zero element, all are 0. So this is again one of those 4 normal forms. Fine. So that means this is till here, this is what? Till here, this is your I3, then I3 comma 0. This comma 0 is what? After this form I3, all other columns are zeros. Okay. Fine. Similarly, till here, this square matrix is your I2. Fine. No, this square matrix is I2. And below I2, I have 0 rows. So this is also your one of the normal forms. So this is again in the RREF form. Till here this is your I3, fine, no, I3. Then this is your 0, and even below also you have 0, even you have 0 rows also, fine. So this is your normal form or canonical form. So this is nothing but the RREF form. So what forms are not in RREF form? So we'll say that the reason why these four matrices are not in reduced row echelon form. So very first thing is what? So here we'll see that this matrix has the number other than zeros and ones also. Okay, fine. This matrix is not in RREF form. What about this matrix? This is 2. So we will not count this even in the REF form, right? And if it is not in REF form, then we are not going to see whether this is in RREF form or not. Similarly, we can find that 5 is again present here, right? Okay, what about this matrix? This matrix is not in REF form only. If it is not in REF form, because of this 1 present here right now, this 1 should be in the right hand side of this one. Okay, so this is not in REF form, so this is not in RREF form also. Even this is not in the REF form only, because this 0 should be at the end of this matrix. Fine, no? So these criteria are there to see whether the matrix is in RREF form or not. Fine. So if you find this class useful, please like and subscribe my channel. Thank you.